Okay, in this video, we're going to look at something called continuously compounded interest. So in the previous lesson, you learned about compound interest, in which you could invest money and you would earn interest at specific finite times throughout the year. So maybe you did it yearly, in which you would earn interest one time a year, or quarterly, where you would get it 4 times a year, or daily, or monthly. Well, what happens if you were earning interest all the time? Like at every instant you're earning interest and you can't put a quantity on that number. Well, this was what leads to the value E. So this is a new math term for you. The number E is an irrational number. It's very similar to something like a pi. It's never ending, it's never repeating, it's a special number. And all this number, I do want to show you where it comes from, but before we get to that, I do want you to realize that the number E is a button on your calculator, and it can look like the E or the E to the X. So you might want to check that out and see if you can find it, because you will need it. And let's go and figure out what is E and where does it come from. So that's what I want to look at today. So the number E, let's make it real simple. Let's say we're going to invest $1 at 100% interest for 1 year. And we're going to go through these values of n, because we said the E is kind of tied to that word continuously, where we can't put a finite number on n. It is just increasing and increasing and going forever and ever. So we're going to start with that compound interest formula that we learned earlier, and we're just going to see what happens as we increase the value of the n, so the number of times being compounded. So I'm originally going to start with $1, and I'm going to get 100% interest, so that's a 1. And the yearly is our first one in our table, so we're going to do this one time, or you're going to earn interest one time a year, and we're going to do this for 1 year. So if you type all this in your calculator, you're going to notice that you get out $2. So you started with $1, you invested at 100%, you get out $2. Okay? Let's see what happens when we change it to quarterly. So I'm going to come over here and I'm going to change this 4, or this 1 here, to a 4. So quarterly means I'm going to get interest 4 times a year. Okay, so if I type all this in my calculator, I'm going to get out $2.44. And that should make sense. If you're going to get interest 4 times a year versus 1 time a year, you would expect to get more money. Okay, let's see what happens when we do monthly. So if I take out quarterly and let's change this to monthly, that's 12 times a year. Okay, we're going to end up with $2.61, or about 2.613. You notice it's still increased, but it didn't quite increase as much as it did from yearly to quarterly. Okay, and you would think going from 4 times a year to 12 times a year, you would have made maybe more money than that. Okay, weekly. Weekly is 52 times a year. So we're going to substitute in that 52 times a year for n. And again, we get a little more money. The more times that we're earning interest, the more money we get. Now, if we keep going using our formula and we do daily, we're going to get up to $2.71. And I'm going to write out a couple decimal places. If we go to hourly, well, we know there's 365 days a year and there's 24 hours in a day. So there's 8,760 hours in 1 year. So if we would substitute that for our n value, we're still getting around 2.71, and I'm going to go out a couple more decimal places here so we can kind of compare. And let's go on to minutely. So 60 minutes are in an hour, so we're looking at about 525,600 minutes in a year. So if I'm going to earn interest that many times a year, again, I'm going to add a couple decimal places, and we're starting to see a pattern. We're starting to see some of these digits and these decimal places repeating, getting close to each other. If we go to seconds, so again, if there's 60 seconds in a minute, now we're at this many seconds in a year. So we're looking at about 31 million. Again, writing that out, we can see even more of those decimal places are starting to line up. And what's happening is it is leveling off. And this value that it's leveling off at is what has been defined as the number E. So E is technically a number, and it's just as that value of the n is getting bigger and bigger and bigger. So it's going to infinity. that number E is going to the number 2.71828, and you can see it there. I would just probably round it off. 2.718 would be fine. We are really just going to use your button on your calculator though. So as that approaches infinity, we get that value for E, so that's where E comes from. So, and we can apply it into something called the continuously compounded interest formula. So when you see the word continuous, okay, I call this the Pert formula because it spells Pert, right? Principal, the base E, we got our rate, and we got our amount after t years. So let's go see how we would apply one of these. Okay, so let's say Ben is investing $2,700 that he has saved from his last 10 birthdays, and he's going to put it in an account that gets 12.2%. Notice it says compounded continuously. So once you see that word, you know you have to use this formula, the Pert formula. Would he have $1 million if he left it in an account until he retired? Well, I'm going to assume Ben is about you guys' age. You're probably about 16, 17 years old. So let's say Ben's 17. He's probably going to work at least into his 60s. So let's say he's going to work for 50 years. Okay? And you could do this with yourself depending on how old you are now and when you think you're going to retire. I think, you know, if Ben's 17, he works 50 years, he's 67. I think you probably have grandparents maybe that are still working that are that age. Okay, so let's look at how we apply this. So P is our principal. So he had $2,700 to invest. E is, that's our natural base, and it's just going to be a button on your calculator, and you're going to have to look for that. And then an account that earns 12.2%. Okay, and we're going to assume that he keeps it in there for 50 years. Okay, so you go ahead and you type that in your calculator, and notice that the 0.122 times 50 is up in the exponent. So a lot of you might have an e to the x button, and then it just pops that already up in the exponent. So would he have $1 million? Yes. He's going to have over $1 million. And that's one of the cool things about compounding interest is time is really important. The longer you leave your money in there, the more money you're going to have, because it's compounding and it's growing exponentially. So sometimes it seems like it's starting out super low and slow and your money's not growing, but eventually as the time passes, it starts growing by leaps and bounds. Okay, so I'm going to have you try this last one, and you can stop the video and then you can hit play to see if you did it right. But Teresa's great aunt leaves her $8,425. She invested in an account that earns 9.5% compounded continuously. How much will she have in 30 years? So if you want to hit pause. Okay, so hopefully you did hit pause and you had a chance to try this one on your own. But we got our P-E to the R-T. Okay, and we type all that in our calculator. And notice she's about $145,649.59. So not too bad on her initial $8,000 investment. Not quite as good as Ben there that left his money in there for 50 years. So kind of some cool things with compounded interest and things to think about that would actually affect you in real life. So when you're getting that first job and you get those paychecks, start saving that money and investing it in your retirement, because when you're younger and you have that and you leave it in there until you're ready to retire, it grows.